This conference will
Good
now be
morning.
recorded.
Hope you are able to see my screen and also able to hear me clearly. Someone please confirm.
Yes, we can see the screen.
Okay, thank you very much. So, good morning. Hope all of you are comfortably in your positions. So, thanks for joining. This is the third day's lesson on our ML Foundation course. So, as I told you, the first 5-6 lessons are more based on little bit of conceptual understanding of what is ML, some terminology. And today, in this third lesson, I want to focus on two things. One is what kind of tools that we will use as part of this course, because earlier on, I told you we are taking what we call a 4-project approach. So we will do as part of this course 4 projects, and we'll be using a set of tools and technologies, but then we'll be using Python based tools and ecosystem. But there are many commercial off-the-shelf solutions also are available. So today I'll quickly and very briefly outline what are the various tools and what is their usefulness as we do the work. And also a second part of today's lesson will also talk about what is a typical process that we need to think of when we are building machine learning based projects, because we are telling machine learning software development model is far more different from the traditional software development model we are all aware of. So again, today's second half of the topic will be on what could be a potential development method or a development process when we start working on ML based projects. That is what we'll do today. And so again, as usual, some of you who are not speaking can mute your mics, and feel free to ask questions anytime, interrupt me. That will make the thing much more interesting. And again, you can wait till end also, not a problem. But whenever a question comes in your mind, please feel free to ask me, so that not only you, rest of the people can get benefited because you have asked a question. So please use that option. Okay, so let me get going on your ML tools for this course. That part of today's lecture, let's go and look at it. So as usual, I always want you to think. I want to trigger some thought process in your minds. So here is a question. There are 4 statements, and then you have to help me whether the statement is true or false. So let me read. At the start of any machine learning project, you face an important choice as a technical team. Let's say your client asked you to build a machine learning based software work you got from your client. Then one question that comes to the team, and that is what actually very important choice. So which language or software should I use? That comes. So you have many options to choose from. There is Python, R, SAS, MATLAB, and many more. In fact, today IBM, Amazon, Microsoft, Google have as a service, machine learning as a service tools and technologies available, which make life very, very easy. So many options are there for you as a technical team when you want to build a machine learning based software project. And the list goes on. But before making this choice, maybe you have to actually need to make another choice. What is that choice? should I go with open source or commercial software? Okay, because both options are there. Open source, it's free, you don't need to spend money on the technology, but you have very powerful commercial alternatives where you may have to spend money. But should I use open source or should I go for commercial? But anyway, this choice depends also on your client's choice as well. But let's say client gave you choice to deal with it, so you have to first make a choice around either open source technology or a commercial alternative, and then within that which one to use. So anyway, these are very standard, every one of you know, but I thought even lot of beginners also are learning, so I just wanted to include these things. So the first statement here says that Python and R are open source programming languages with rich open source ecosystems. Python and R are programming languages with rich open source ecosystems. True or false? True. Everyone knows. So Python is actually today also very industry graded professional machine learning models are being built by many companies using the Python ecosystem, and it's very popular. Almost 60 to 70% times people are using Python ecosystem because it has very powerful libraries, reusable software, as well as lot of ready to use algorithms, machine learning algorithms. So people are using more importantly, actually Google uses a Python based ecosystem, and that's why a lot of people also go for it. But again, R is also equally interesting open source statistical learning programming language, and this is more widely used in the academic institutions, students studying economics, biology, doing their modeling around statistical modeling. R is also an equally used open source system. Okay, so you said true, that is true. Python and R are programming languages with rich open source ecosystems, and Python is very kind of popular in the ML area. Okay, the second statement, let me read. Because they are free to use and customize, like Python and R, they are open source software. So typically, open source software tends to attract huge communities. That means more people to improve it and fix it when it breaks. You agree or not?
Yeah.
So though there is no commercial organization behind this technology, but there are very passionate communities. They keep on extending, building new capabilities. And now for Python, definitely with Google using it in all its ML AI area. So a lot of community help is there. So that is why Python is getting popular day by day. Okay, so that is also a true statement. Now let's come to some of these commercial alternatives. MATLAB is a very well-known software from engineering colleges onwards. We know MATLAB also has very powerful ML technology and ecosystem. Similarly, there is another firm called SAS. Both of them have commercial software. MATLAB has a technology called MathWorks, and SAS software actually comes from SAS Institute. Basically, MATLAB is a software developed by MathWorks, and SAS ML is developed by SAS Institute, and they get specialized support and better version control and maintenance. Do you agree or not? So there is a commercial organization behind these technologies, and they have a good roadmap, and they have a lot of money. And anyway, they make money by selling this technology. So they have much better specialized support in case you are stuck somewhere, and also better version control and maintenance. Do you agree or not?
Yeah.
Yes, it is true. That is why, especially some client organizations, they want to depend on some very solid, stabilized technology platform so that they are not unnecessarily caught with some unknown issues with an open source technology. They may still insist on using some commercial technology where we have to pay money, but there is an advantage because we are paying, because there is a clear cut roadmap available. If you are stuck with something, there is a large engineering team keeps on working on maintenance, and they will keep releasing the new things. So that is one advantage definitely with the commercial technologies, but only thing is that you have to pay for it. Okay, so the last statement I want to read is that Python ecosystem has scikit-learn. These are the ML off-the-shelf ML algorithms, a powerful general purpose framework, and also has specialized packages for deep learning and NLP. Python has scikit for ML, as well as very specialized packages for deep learning and NLP, such as TensorFlow, Theano, and Keras. These are all built on top of Python. These are the technologies actually Google uses to do their solve their deep learning problems. TensorFlow, Keras, all that. So is it true or not? Actually, it is a true statement. Just I want to tell, but Python actually has very powerful tools already, and also they are being improved every day, and a huge passionate community. Again, powered with such an organization like Google kind of organization, Python is still ruling the machine learning technology at this moment. And anyway, for this particular learning opportunity, we are also using Python based tools. Okay, so that is what we will talk, what Python based libraries and tools we'll use. I'll just quickly introduce you to that. That is the goal of this lesson. Okay, so basically, as I told you, this course is not just about understanding concepts, though the first 5-6 lessons are more understanding concept. Then immediately we move to hands-on practice of work now. So it's also about the tools of the trade used by professionals. So we will be also using that. So in this course, we will use a suite of Python libraries for this course. So what are those Python libraries? Yes, the basic thing is we will use Python language, programming language. Okay, because again, as I told you earlier, it is not, we are not doing a standard traditional software development that requires us to write lot of complex logic, large programs, and lot of our managers, and especially my community, that is testing community, we don't like to break our heads and write complex logic. So machine learning is not about writing such complex logic. It is just to organize a method to read a data set, clean that, and manipulate the data set a little bit, and then create a structure in such a way that we enable some ML algorithms to learn it and build some models and test those models with some data and evaluate metrics, that kind of work. So we'll be using Python language to build that basic coding infrastructure to build models. But this is not really very complex programming. So any of you who think that, hey, programming is it's not my cup of tea or coffee, so don't think that. It is actually ML software development is very suitable for such people who have little bit of dislike to doing very complex programming. So we will use Python language through this project. And before we get into our 4 project approach, what I will do is that some 5 to 6 lessons on a crash course, Python for data science crash course. I will do that. And when we do that course, during this 1 hour session, I will take you through the course, and I want all of you to sit in front of computers and use that 1 hour to type in that code. That is the best way to learn. I recommend that way, because if you only listen to this class and then later on I want to sit in front of computer and try, then some of you may not do. So that is why this whole course, throughout the 4 projects, each 1 hour that we are going to spend writing code, all of us will be writing code together. Okay, so that you don't need to unnecessarily waste 1 more hour to do that. So we will use that. So Python language will be used by us as part of this course. And what we will cover, Python programming language, is a crash course for performing data science work. We will not go into details of Python. We will not teach Python to build complex web applications. That is another kind of work. So we will only focus on Python for data science, and it will be a crash course. So when we talk about Python for data science, Python for data science work, it has come up with a lot of useful, reusable libraries. One very important library is called NumPy. Some people will pronounce it as NumPy, but what does it mean? It's a numerical Python library, because machine learning algorithms use a lot of numerical computing methods. Similarly, when you are as a ML developer, you are also doing a lot of work on uh, tables and data inside the tables and calculations to understand the data and then apply the right algorithms. So NumPy is a very important library which is developed on Python. We'll be learning. So in fact, as part of our crash course, we will spend at least 2 lessons on learning NumPy. So NumPy basically uses Python language. Actually, Python has very interesting common data structures like lists, dictionaries, sets, tuples. On top of that, NumPy has come up with a very interesting data structure that's called n-dimensional array. Using that n-dimensional array, uh, we can do very efficient uh, tabular data computations. Like if you think them tabular data as matrices, so that kind of maths can be done element wise very, very productively. Java takes many seconds, Python takes only few milliseconds. So because of that good kind of ND array kind of data structure, okay, C beats Python from a efficiency point of view, but NumPy provides that kind of capability. We'll learn anyway. NumPy again, NumPy for has some set of tools. We call them actually as random tools. In any machine learning work, we need to play around with data. We have to build intuition, because we are dealing with large tables of data. There are thousands of columns and lakhs of rows kind of data. When you see that, for a ordinary human mind, it is too tough. Then we will actually lose interest. But using NumPy, you can actually build intuition by using some of these random tools and pick up few things and apply on smaller set of data some mathematical techniques and understand yourself some patterns in the data, so that you can use the algorithms in a much better way. So we will learn those things. NumPy is a very important library. Then there is another library called pandas, which is also very useful library, because we are dealing with data, large uh, data sets. We need to also clean the data set. We have to manipulate the data set. We have to analyze the data set. We have to visualize the data set. If you want to clean it, if you want to engineer new features into the data set, first you have to understand the data. You have to understand the data from the statistics, numbers and number crunching. Then sometimes visually you have to see some bar graphs, and variety of graphs are needed to visualize the data. So pandas as a library, again built on top of NumPy, is very useful library for exploratory data analysis and data cleaning, feature engineering work, and it makes your life as a ML engineer very simple. Okay, so again pandas uses some of the basic Python data structures, but it came up with two new data structures. One is called pandas data frame. So how to look at a big table and play around with that kind of data structure. And then again, tables are made up of a lot of columns of data. So they have another data structure that is called pandas series data structure. So once you understand these basic data structures and understand the basic working of pandas, you can do some of this work very easily. So that is a very important library we will learn. And again, on top of NumPy and pandas, there are visualization tools that have been created. So there are two which we'll use very predominantly in our projects. One is called matplotlib. This is basically how to understand a particular data by putting variety of graphs. So that library is called matplotlib. But then on top of matplotlib, again Python community built another very good library called Seaborn. So it will enable you to understand the data by visualizing in very colorful and very fancy pictures and graphs. So Seaborn and Matplotlib together, they give you that capability. And of all that, the heart of Python ecosystem for doing machine learning work is this, the scikit-learn algorithms. There are reusable, top quality ML algorithms pre-written for you by a community of people using all the complexity they have kind of abstracted and made it for you. So we will be using out of the box from scikit-learn these machine learning algorithms. So this is the ecosystem using which we will build our 4 projects. So that's what I wanted to tell you. Again, quickly to recap, as I told you, NumPy and pandas are core libraries for data science. So why these are very important. If some of you want to make a career shift and go as data scientists or participate in machine learning projects, then you have to perfect using these 2 libraries. So what is the meaning of perfect? Let's say you have a large data in front of you. Then you want to get some idea from the data. So you are asking a particular question in your mind. Okay, I want to slice it, dice it this way with this criteria. And I want to see this data, then I may get better idea of this data. So that thought process in your brain should translate into pandas or NumPy commands, and they have to go onto the keyboard and type it. So your mind, your hands, and your pandas tools have to work in a very synchronous way. In fact, I have watched some good data scientists working. They actually use these tools like they're thinking using these tools. Okay, so any one of you who is really interested to make a data science career, then we will teach something, but there are so much of tutorials available, and you can take some data sets and keep on practicing, then you will perfect it. But you must perfect it if you want to be a good data scientist. So these libraries will help us from start to finish explore data sets, cleaning data sets, storing, importing, and wrangling data. All these words we'll talk about in our projects, but these tools are very handy. So you have to kind of be extremely conversant with that. Then you will make that career as data scientist. Then again, from a data visualization point of view, lot of times If you see only numbers and names in large data, we will not understand even some good descriptive statistics calculated, but still they don't give you a good picture in your mind. So always graphs are very important. So for that visualization, as I told you, matplotlib and seaborn, these are the tools we use. And then, as I told you, the third important thing is the scikit-learn library. So there are dozens, actually hundreds of best-in-class algorithms right out of the box available there for you. And also, to build professional grade machine learning models, there are a lot of other functions that are needed to clean the data, to conduct feature engineering activity, to pre-process the data, to scale it up in a proper way. A lot of functions are there, cross validation purpose. We'll come to all those things. You will do there only when we hear the terms are very complex, because we don't know. But when we do the project, you will think, oh, is that easy? So that is reality of the thing. So we'll go into everything. And also they have a lot of tools for model evaluation and selection. So we'll learn all of them. So in this course, we will use the Python libraries. So be ready for it. Okay. So again, to do this course, we will use an IDE. Data science popular IDE is actually called Jupyter. Okay. It's an integrated development environment for data science and ML projects. So Jupyter actually stands for Julia Python R. So basically, if you look at history of Python a little bit, when Python was used by scientists to do some high-end maths work and share with other scientists, they wanted to share using a set of notebooks. Notebooks are nothing but you can actually put your documentation, the code, and inline visualizations and share it with the rest of the people. So if I take your notebook file, if you are developing a Python based notebook, still the extension of the file will be .ipynb, interactive Python notebook. So if I share with someone, I can use this IDE and click it and see, and I can manipulate the code and see the different visualizations. So it's a very useful, easy way to do this kind of data science and ML projects. So we will be using Jupyter notebook. Okay. Anyway, I'll give you an installation instructions. It is very easy thing. So all these things what we ever talked are all available in a single software distribution. Basically, a software distribution is nothing but a bundle of files, tools, software, the IDE that we are talking, and our programming languages. So there is a distribution called Anaconda. So you can go there, and it takes less than 5 minutes. You can set up all of the things and you are ready to go. Okay.
Python
So
and
basically,
Anaconda,
I'll
nice
send you.
combination.
Pardon that.
Python and Anaconda are very good combination.
Yes, yes, yes. Python. That's why I think people have named it Anaconda. Okay. Yeah. So I will send you at the after this class is over. I'll send you a small one-page document where you get Anaconda and how to download it based on what machine you are using, either a Mac or a Windows machine. So basically, download and install the distribution. Okay, it will come already. It will have Python programming language as well as all the other things: NumPy, Pandas, Matplotlib, Seaborn, and scikit-learn algorithms. And also it has Jupyter Notebook IDE. Actually, it has Jupyter Notebook IDE. Then it will have uh, Jupyter Lab, a little bit of extension of that. And also there is the R Studio, because basically it was IPYNB, Interactive Python Notebook. Then I think some organization has funded and they told, let us expand this whole notebook kind of IDE for rest of the languages. There is a language called Julia, and a lot of people use R. So it has provided everything for all these kind of programmers. Now actually Jupyter notebooks are being extended for Scala, Java language, and all that. So okay. So but we will be using all these things as we progress. So before I conclude on this very basic lesson on the Python ecosystem, so just I want to check whether you are able to remember whatever I told or not. It is not rocket science, but I want you to answer these questions. So dash contains dozens of best-in-class ML algorithms right out of the box.
Scikit-learn.
Yes, scikit-learn. Okay, so that's great. So keep that, because right now our goal is to just learn these words and place them in the right spot. That is the only idea right now. Dash offers optimized tools for numerical computing in Python, and Pandas offers tools for Dash. Dash offers
NumPy
NumPy offers
data analysis exploration.
very good. Very good. NumPy offers optimized tools for numerical computing, and Pandas offers a lot of tools for data analysis and exploration. Very good. Now the third question, the two important tools for data visualization in Python are Dash and Dash. Anyway, two only are left. So basically Matplotlib and Seaborn, these are the data visualization tools in Python. We use them very heavily as we build ML projects or data science projects. So at least position them and keep in your mind the names and what they do. Okay. So with that, now what I really encourage all of you is that I'll send you a one-page instruction where to get this Anaconda distribution, configure your systems, and be ready. Then when we start doing the practical work, then ideally what we will do is that all of you sit in front of computer, maybe minimize this learning screen, or again it will be write in the code that I am talking as soon as you are seeing it. That is how we will build these projects together. Though virtually we are doing, we'll figure out how to build that. If you do that, you will save time, and your confusion regarding any potential topics will be removed in your minds. That is why I recommend that kind of method, and we will do it. And some of you, if you are unable to do it anyway, these lessons will be there. Then you can offline also check your code, but still do everything hands-on. Then you will be more confident. And anyway, those of you who want to make data science careers, there is no other way for you. Anyway, this program will not teach you everything. This program will actually build some curiosity in you and give you some basic inputs. But on top of that, you can build more skills and be professional data scientists and machine learning engineers. That is the goal of this course. Okay. So with that,
Madhu,
yeah, go on, please.
yeah, one question. Like by when we should be ready with this installation? Because
Okay.
we might need some permissions from our admin teams or ID teams or to install softwares.
Okay. Okay, that's a good question. So right now what we will do is that there will be another conceptual class, that is tomorrow onwards we'll start. That is actually the most important conceptual class, and that is what we call model complexity. Okay. So after that we will start maybe the next in this week, the third class, that is on the Friday, we'll start with Python programming language crash course. By that time you need installation.
Thank you, Madhu.
Okay. Yeah. Okay. Fine. So let's move on. So now the second half of today's lesson, also I want to quickly talk about a potential process using which we must develop ML kind of projects. Okay. In fact, if you go and search for literature like SAS Institute, MathWorks, because they have come up with a lot of very powerful commercial technologies, They also promote a very good process models to use the tools, and large teams can build professional grade ML models. There are very, very good process models. But my goal to include this lesson is that if you as a team want to build really serious ML projects, then along with tools, we need also a solid and good process. That is what we do in the regular software development. We have a lot of good tools. We have gained technology skills over a period of time, but then it is not enough. We also apply a particular SDLC model, like a V model or agile model, and using that model only we develop software, because that will guarantee you that you are going in the right direction. So for performing machine learning also projects also, we need a process. Only problem here is that it is machine learning kind of software development is different from our traditional software development, at least in some aspects. So we have to fine tune the process also to develop this kind of software. So as I told you, there can be when you are working in a real client project, your client may dictate a particular process model, or your organization may have some particular process models. And as I told you, the commercial tools have very solid process models they recommend. And here in this class, my goal is to tell you that it is important. Don't undermine the importance of applying a good process. In fact, the 4 project approach, when we do, we will also apply a process. Okay, a template I will use, and the template we will repeat across 3 projects. And because of the repetition, you will remember the template, and then the template will become your a potential process for building models. So anyway, that is the goal of this lesson. So I'll quickly go, and as usual, I want you to think a little bit before we talk about this. So the statement I am making here is that many machine learning projects fail. Today also, a lot of, if 100 teams are trying something, 90 teams are failing. Okay, especially they are failing to get into production. Means really a professional grade machine learning model which is in production, like a Netflix recommendation engine. It is integrated into their whatever total Netflix e-commerce site, and then it keeps on getting new data, new behaviors of their current users, and it keeps on readjusting the recommendations to specific customers about what movies to see, recommended all those are all automated, and it happens automatically. A new data comes, a new recommendation happens, and another minute something happens, it changes. It's actually infinitely scalable kind of way they have. They're using these models in their business. Okay, so what we are telling is that many machine learning projects, they fail to get into production, as there is massive difference between building a proof of concept ML model, like I take one data set, experimental sake, I do all the steps and build a model and try it for a while, whether it is predicting well or not. That is what I'm calling it as POC kind of work. There is a huge difference between creating a POC and doing it continuously, indefinitely at scale. That's why I used Netflix example. They do use their models continuously, indefinitely, and at scale. So if you are working in your companies now, and you are going to work in projects, and your customers are paying money for it, customers will not pay money for proof of concept work. Customers will pay money for only a highly massively scalable production quality industrial graded machine learning models, which they can deploy and use it in their business to make their business better. Okay, so it is hard to take a desktop scale ML algorithm into production. Okay, that is the reality. A lot of teams Again, I picked it from some Google document only, this statement, and I'm keeping it. I'm not inventing it. Okay. But what could be the reason why so many people are failing? That is our question that should come into our minds. Anyway, the first point I'm making there, you have to say true or false. Because of poor data quality, machine learning algorithms will be doomed to fail in the real world. True or false?
True.
True. As I told you, a very high quality data can be used and to build a very accurate model using very ordinary algorithms. So that's why I told, anytime good quality data beats fancier algorithm. That is the rule of machine learning. So that is why last class also I told, we use significant amount of time on the data issue, and that is why data science is the real top-notch skill that is needed to build these models. So we will come to that in this whole thing. We'll keep on repeating it about the importance of data quality. So second point I'm making is, because you are going after solutions that are cool but useless, and you overlook simple solutions that may be just effective, that is why you may fail. So do you understand the
True.
statement? What
True.
I'm telling is,
That's true.
there is a problem. That problem can be solved by a simple traditional software model, but nowadays people are fancied by this cool technology called machine learning, AI, because everyone is talking, it's popular. So we convert every problem into a machine learning problem and then screw up that solution. So that is what is the second point really saying, because you go after solutions that are cool but useless, and you overlook simple solutions that may be just effective for a particular problem. So that is again a true statement. A lot of times that is also one of the reasons people started making every problem as a AI problem now, because there is too much discussions are happening. That is a tendency which we have to avoid. A lot of problems can be solved using whatever we know already. Okay, because you lay out a systematic way and define good milestones for navigating open-ended problems, you will fail. True or false?
False.
So if you lay a systematic way and good milestones and navigate through those milestones by getting answers for the open-ended problems, only we will succeed. We will never fail. That is why the process is very important. False statement. Okay, so let's move on and quickly talk about a templatized process model. Okay,
Madhu, I have a question.
yeah, please ask.
Yeah, this is Meena. I just posted it there. When you said the POC, proof of concept, cannot bring in scale, right? Commercial grade production. So what is important for commercial grade? Is it the processing power of the machine or the big quality of data? I mean, the large data. As a POC, I may not have access to large data. So with the same POC model I built, if I have the data, can I convert into a commercial grade?
Yeah, so basically commercial grade means definitely the data and data quality issues that you raised are very, very important. But once the model will be deployed into a standard software application, models will not live on their own. Models will finally be integrated into a software system, enterprise software system. Now this enterprise software system will be deployed into production. When it is deployed into production, it has to, again, the data continuously keeps coming and data continuously keeps changing. So this model will have to keep on learning with the changing data. That capability it has to have, and model's performance will have to be continuously monitored as it is in the production. So a feedback loop has to go, and then only the models can be used by big businesses in a useful way. That's what I'm talking, Neela. Did I
Okay.
answer your question? Yeah.
Yeah, so it's the entire architecture of this building, this model decides,
Yes.
right? It's not just,
Yeah,
yeah.
absolutely. Finally, when it is in production, it has to kind of continuously, indefinitely at scale, keeps on changing. That kind of thing we have to develop. That requires a careful evaluation of a good process model. It is not as easy as playing around on our desktop computer to learn. So that kind of model now, whatever this COVID time, there is a lot of criticism about these models. Today also I was watching on CNN about how pessimistic earlier the models have projected. But then as the new data is coming, new data is changing, they are projecting different kind of predictions now. It is a maybe natural process, though they are unnecessarily getting criticism, but the data is changing. The facts are coming every minute, every day, and they are being fed into that, and the machine is learning new things, and based on those new things, it is predicting new ways now. So
Okay,
yeah, okay,
thank you.
okay, thank you. So let me now move to a little bit of process model. Again, as I told you, all this is not created by me. I saw in some paper uh, in the Google, and then I created this. So imagine that it's your job to implement machine learning technologies into your business environment. You must be wondering where to begin, what kind of problems to expect, and how the specific related projects and services differ from what you are used to. We are used to traditional software development. If we want to build this new capability into our organizations and start building more projects by more people, because it is not one person will not do that. In any typical ML building activity also, there are project managers who are important. There are business analysts and domain experts who will be important. Data scientists will be important. ML based software engineers will be important. All people only can use as a team effort and do it. Whenever a team is there, a process is a must. So I'm talking about 5-stage implementation of ML projects. The first one is, anyway, for any project, what we do traditionally also, determine objectives, metrics, and constraints. We'll come to each stage in a little bit more detail, but don't jump to writing some code. Take some data set, start doing whatever you know, and try to say that, hey, it is now model, now take it and put it into your software, integrate it. No, it is not that. First, okay, what is this problem? What is the expectation? What is the objective? Who is going to use it? And when can I say that I built a good model? Then I can integrate it in a particular software system. That kind of basics have to be taken care of in the stage 1. The stage 2 is now, okay, where do I get data from? Will customer supply the data? What is the nature of this data? Or do I get a continuous data from some API, or I have to scrape through some web based tools, whatever. Collecting and organizing the data, and then cleaning and feature engineering the data. These are all very, very important things. Based on the problem you are trying to solve, you have to prepare the data. So typically, as I told you also, this aspect of data cleaning, feature engineering, this step is a very long, open-ended step. Okay, it takes a lot of time. So we use all those tools to do that. So we have to carefully understand this step. And the stage 3, once, typically what happens is that there is a raw data, then based on the problem we are solving, we clean it, we remove some features, bring in new features from existing features, based on a lot of analysis we do about the data. Then we prepare a data using which now we can build a model. Typically people use that particular table as ABT. So coming from a raw data to ABT stage. ABT is actually analytical base table. That is the table now I can give to my computer to learn from that table. So that stage will take a lot of time in any project. Anyway, we will also experience that. Then once that stage is done, then it is the organizing. Okay, because anytime when you are building models, to build models, there are many algorithms. Not only many algorithms, but algorithms with many hyperparameter settings. Okay, so you cannot teach your computer with one algorithm and say that it's fine. No, maybe based on your objectives and metrics, you will not be able to achieve that metric with only using one ML model algorithm and one setting. To achieve that, you have to actually teach your computer with the data using many algorithms and with many hyper parameters. So that requires some kind of framework to appropriately train your model. That is where our scikit and our Python tools will come very handy. Though we think it is a very complex activity, Python functions have made it very easy. Okay, but that is typically in a standard software development, we never have these two, stage 2 and stage 3. Stage 1 is requirement analysis, that is there, it is here also. But the stage 2 and stage 3 are very specific to our ML based projects. Now what is stage 4? Stage 4 is now, okay, I built a model, I evaluated its performance, it's working very well. Now let me take that model code, whatever code is there to do that model, let me take it and put it into the software in which I want to use this model. Okay, so that is called integration and testing. Again, this is a well-known software engineering step we understand as traditional software development people. So that is we have to do. And the stage 5 to build industry grade thing, model monitoring. So continuously monitoring the performance of the model and giving feedback and adjusting the model's performance to evolving changes in the input data. All those things have to be taken care, and that can be done by monitoring carefully the models that are already deployed into production. This is again a typical 5-stage thinking we have to build really professional and production quality ML projects. Okay, let me quickly go through each of these steps. So basically stage 1, as I told you, we need to determine objectives, metrics and constraints. So definitely you have to spend some time, ask some basic questions. Actually, what is the problem we are trying to solve? Sometimes we have to ask, is this data driven AI based techniques are the right things to solve this problem? A lot of times we may realize that actually it is not. Then we don't need to even start the project by doing ML way. Okay, then who are the key stakeholders? This is a very important thing in any project. Here also it is important. So for any machine learning project, there is a way already people are using. Okay, let's say in a hospital for a cancer diagnostics, there will be CT scans. CT scans will be given to doctors. Doctors will look into that and then they report what is their understanding of the diagnostics, and then that is how they may be doing. Now we tell that hospital, hey hospital, now I will actually give you a machine which will do what doctors are doing. And so basically they have to change the process. Now doctors will suddenly become irrelevant. Any role which becomes irrelevant, they will put a lot of resistance also. So who are the key stakeholders? What is the politics involved in that? How to convince them? Who gives me data? Once I create a model, who are the experts use this model to do their business or do their work? So these are also very important questions. These are important in other projects also. Here also, it's not only technology. A lot of times things fail because of people. So we are taking care of some people issues by asking these questions. Then you have to, again, as I told in the first point also, what does machine learning offer over the existing solution? if the existing solution is good enough, actually do I really have to do a data-driven ML kind of model-based software solution? If the answer is no, don't do that. That is why it's important. Then for every project, start the project with quantifiable win condition. These are typical exit criteria for our projects. So when can I say that I have built the model with whatever objective criteria I set during my first stage? So setting those quantifiable win conditions are very, very important. Again, different contexts, like an example of a quantifiable win condition is that if already there is a model that is existing in this field with X% accuracy, whatever is that accuracy means, we'll come to that based on what regression or classification or clustering, there is some metric using which we can talk about accuracy. Let's say there is a X% accuracy in the current existing model. So my win condition is that if I am able to build a Y% where Y is greater than X, that's my win condition. Or some places in some kind of contexts we can do in a much more quantifiable means, like say if you are building a real estate transaction price model where machine is predicting. So there are experts who can also predict. So let's say if my machine can predict plus or minus $15,000, that way also we can talk about it. So having quantifiable win condition is also very important. So stage one, again, quick recap. What is the problem you're trying to solve? Be able to express it. I'm predicting attrition, whether an employee leaves or stays. I'm predicting real estate transaction price or something like that. That will in fact give you a clear idea what you are doing, regression or classification or clustering. So again, stakeholders are important. Then if machine learning doesn't offer any more things than existing solution, even don't go after that. And for every project, before you start itself, have a quantifiable win condition and articulate it. Then only you know you are going in the right direction, or whenever you stopped, you know, yes, I have achieved what I wanted. So that is the first stage. The second stage, as I told you, about data, which is the key. So you have to figure out who will give data, if you are collecting data, from where and how you are collecting the data. Then always in machine learning, having a lot of data, even if it is raw data without pre-processing, that is more valuable. Then you can look at the data and create strategies to improve it. Okay, so you have to take that responsibility based on the problem that you are solving. So always get raw data and then improve it based on the problem you are solving. Then these three items, like exploring the data, cleaning the data, engineering new features, that's where actually your pandas as a technical tool will help, but it takes a lot of time, and we'll do all these steps very, very carefully. Then, as we told, quality of data. A better quality of data beats a fancy algorithm at any time. That is the rule of machine learning. So that is the second stage. So by the time we completed second stage, we have a table that can be used to train the machine. Typically, in machine learning terminology, we call it as ABT, analytical base table is ready. Then we use that analytical base table to create a process of training. So again, when you train, it will, after immediately training, and you have to test also whether the model is predicting correctly or not. So you have to use the same training data to both train as well as test. So you have to organize a strategy for that. Then, as I told you, you will not build one algorithm and make the machine learn with data. You will use dozens of algorithms with thousands of settings and learn the computer with those multiple things, and make multiple models and test multiple models and evaluate metrics, and you will select a winner. this whole process looks very, very complicated. That is where you have to use what we call build model pipelines. Again, don't worry, we'll talk about all of those things. Then declare hyperparameters to tune, then fit and tune models with cross validation, that is test and train, kind of how train and test splits, and how to use that to do a process of cross validation. Again, if you don't understand the terminology, don't worry, everything by the end you will understand fully clearly. That is my goal actually. So then you will evaluate models and selective analysis. These are not standard software engineering processes. These will happen only in case of this ML project. So then the next one is pretty straightforward. Now I have a winner model, a Python class I created. Now I give it to my development team. Now it is about my development team to integrate that class inside their whatever software, mobile app or enterprise application or a desktop software, whatever. They have to integrate and then do a testing. After the model is trained, it is integrated into the IT system. That is a regular software engineering. That's where our other skills, our teams, software engineering teams will come. Then again, our standard software testing people will come into picture now. They do practical end user tests, keeping them in the kind of view of important stakeholders, end-to-end testing. But again, there is another topic that is important. How do we test models? That is also a very important software testing topic. Maybe a lot of you are software testers. Towards the end, I will even talk about that, how to create a test strategy to develop, to test computer models, not the applications. Here we are not talking about that. Here it is standard system test here, or large scale start to finish test. Okay, then measure the accuracy of the model and actual achieved economic effort. Actually, really it solved any problem. Did we achieve something? That also we have to assess. Then we will deploy it into production. And once we deploy into production, constant monitoring of the production use of the service for quality, and keep on improving. Regular additional training on newly collected data, and model keeps on improving. We keep on tuning the model, and it becomes a proper loop. And that is the kind of AI technology that will really help the business. And as software teams working in large companies for our customers, we finally have to prepare ourselves to build such kind of technology. But somewhere we have to learn. So we are learning initially. In the process, we will develop models. But my goal will be, at least in one project, we'll go to a step where we not only build a model, but take that Python class and use it for how to integrate it into a software. That also we'll do. But these are the 5 stages. So what are the 5 stages? Stage 1 is determine objectives, metrics, and constraints. Stage 2 is assessing data. Stage 3 is model training. Stage 4 is integration and testing. And stage 5 is model monitoring. So before we conclude this class, let me check your understanding. Okay. So I have 5, not stages, but within the stage, we do a task, as I described all the 5 stages. So we have to keep them in the order in which they occur. So first task into 1, the last task into 5. In the right side, they are in different order. What you have to do for me is that you have to put them in the right order. So what will go into 1 out of this 5? Constant monitoring the production use, exploring the data, cleaning the data, and engineer features, have a clear quantifiable win condition, building model pipelines, practical end user tests. Which will go first?
Quantifiable will
Storing the
Quantifiable.
data and getting the
Okay. Yeah, have a clear quantifiable win condition, because this is what happens in the stage 1. Okay. So after this, what will happen?
Exploring the data.
cleaning the data.
Yeah. So we will get into the second stage of data assessing. So exploring the data, cleaning the data, and engineering features will happen as a second task. What is the third task?
Building model
Building
pipeline.
model. Building model pipeline.
Building model pipelines. And then what happens?
Practical ID.
And user
Practical and user test. And
fifth
constant
one,
monitoring.
constant monitoring of provisioning. Very good. So thanks so much for your participation. So with this knowledge check, we have concluded this lecture. Now, you have any questions, please let me know. Any questions?
No, I think you explained.
Okay. So if you don't have any more questions, that's great. Thanks for your participation.
Madhu,
Go
just
on.
when would you give us all those requirement of Python and other installation material so that we can be prepared?
Yeah, I will actually give you a one-page instruction sheet to kind of install from the Anaconda distribution all the tools. Today I'll send it to you.
Sure. So it's same for Windows and Mac, right? The instructions.
Once you go to the Anaconda distribution, the location, you can download. If it is for Windows, one place. If it is for Mac, another place.
Okay. Thank you.
I will send you a single one-page sheet of information.
Sure. Thank you.
Okay. So, okay then, learn and have fun. Have a wonderful day, everyone. See you again.
Thank you.
Thank you, Madhu.
Thank you.